This is a 2016 Bushtracker. It's got a fair few modifications over a fair few different like electricians, different like TV and satellite people that have installed different pieces of the puzzle. The battery system is down here with, at the time, probably would have been a state-of-the-art battery. We've got a whole heap of switches and a drive 60 amp 12 volt charger, 30 amp 12 volt charger, 60 amps AC, and then the solar panels on the roof are old Jarrod 150 watters. Which I'm pretty sure for the same footprint size, what are we, 1480, they should turn these 150s into 200s or 225s. And then we've just got all the joins are in a BP box, which we'll probably, not sure what we're going to do with those boxes yet. We'll have to change all the connections to MC4s, definitely. And generator box, so like dual supply with shore power and generator. It's also got a Comfort 210, which is essentially a 12 volt energy source. It can create up to like 210 amp hours of energy with like a chemical mixture. And then you've got obviously, yeah, I think there is all your 240 stuff. But yeah, so just giving you a run through first of what we're dealing with, and got a whole heap of satellite and cell phi and telco stuff up there, and yeah, there's a fair bit going on here. So we managed to get the battery out in the battery box, which was the cells. This is what's been left for us to play with. Now there's a lot of things in here that, like I said before, a lot of different people have installed different units. So now it is our turn to go through and label everything, work out what's what, and work out some new cable routes and some new mounting. Some things like the compressor is probably going to stay where it is or very close to. You've got a bit of length on the ear line. We're basically going to try and fill the back wall with the whole 3 kVA inverter, which should work, and just work out, do we want the cables this side, do we want the cables on this side. So yeah, it's just a whole matter of tracing, labeling, working out what has constant power, like this fuse panel, what has power from the battery through a fuse panel, which is through this stuff, and then yeah, working out all the AC stuff and where it goes and where it's coming from and whatnot. This is the battery and the cells that were in there. If it can get the focus on there, they were actually 400 amp hour 3.2 volt cells. So it's a 12.8 nominal voltage 400 amp hour unit with the Jarrod external BMS. It's not going to be an awesome, I guess, size comparison, but that there is 700 amp hours compared to the 400 amp hours, and this one here is probably 7-8 years old. So just shows the difference in lithium technology and footprints that we can now get batteries down to. We've hooked up one of our batteries just to test some things. This will do all of our exterior lights. That's controlled by a remote. We've worked out most things and worked out what needs to be connected and disconnected. This fuse panel will almost just need to be deleted. I just got to work out what that brakes one is. All the stuff that was in the BMS can disappear. We might even be able to reuse some of those cables. Whoever wired up the exterior Nava lights is a bit of a doofus, because they hooked it up to the battery side of the shunt, so they wouldn't have been reading through the battery motor, which is a bummer. But anyway, we see that a hell of a lot. And yeah, once we've worked out everything, we'll just disconnect our battery and yeah, get cracking. We're just working to remove and move these channels here that are sticking to the roof. We're just working on moving them over about 9 to 10 mil, because the panels that were on there were 660 wide and our panels are 670 wide. So we're just trying to squeeze them over, and we'll probably flip them as well so they flick inside rather than outside like they are at the moment, and then re-stick them down and use stainless steel rivets to mount the panels rather than just like a Phillips head screw. We are also going to take up the all of the solar conduit boxes. They are connected with BPs at the moment, which isn't compliant for a system of these days specs, and it will allow us to also fit the 225 watt panels instead of the 200 watt panels. So yeah, that's where we're at. I completely missed filming anything yesterday because we were so busy just trying to work out what things were doing and where things went and pulling some stuff out. This is where we're up to. The customer was going to try and get us to incorporate all this stuff into a new fascia, but it's not going to work purely just because there is an absolute monstrosity of cables coming through this, and then there's other units that are just sitting loose inside there as well. So we're going to reface this panel, and like you'll delete the battery monitor, delete the inverter controller, and just rejig it so like things are the same size. So like this is the sat dish, and that's his like energy, what do you want to call it, an energy maker. Well, because they're the same size, we'll mount them like together, etc. Keep the fusion where it is. One thing to note with these, the plugs on these can be, the plugs that are directly on the back of them can be a bit of a punish, because it didn't have power and all I did was unplug it, plug it back in, and now it's working. So, and I've had that happen before on the fusions as well, so something to take note of. We'll keep the switch panel, taking off the 240 stuff, and basically what I was doing yesterday afternoon, I'd plugged it into shore power, and I was just trying to work out what each of these 4 power cables did. So you got like 2 AC ins, one from a Jenny, one from your inlet, and then 2 outs. One goes to the van, and then one goes to the box on the front of the vehicle. You got a power point in this cabinet and a power point in this cabinet. You'll see it just up there. We've got a lot of the stuff off, which is good. That's going to be easy to come off, and then it's just the fuse panel and stuff, which we're going to start doing shortly. And we've just labelled all these cables, you'll see in there, and then we've labelled them up the top as well, just with our labeler, just so we know what on earth is what. You've got like extra solar blanket inputs that went into the DC charger, so we'll probably in turn actually adding another solar controller just to look after the solar blanket input. And then this is everything that we've put out, and the solar panels. I'm going to try and chuck some of that stuff on Facebook Marketplace and get rid of it for the customer and try and make some money back for him. Now this is one of the fun jobs. Had to use a couple of different methods to actually get the sticker off, and then we've had to clean the surface. So clean the sticker off the surface as much as we can, and then clean the sticker off the bottom of the brackets as best we can, so that we know that we're going to get a good surface. And then we've just hit it with like a dishwashing detergent mixture and just gave the whole top a wipe down, because underneath the panels there was actually like just grime and mold and stuff starting to build up. We've taken off the solar boxes that were there. We're going to keep the brackets for all the 225s, and then the 2 110s we're going to mount our own brackets up and stick them down. And the original solar comes through that box, which I'm going to work out today, work out what we need to run from the tunnel boot where the like main electrical box is. From this area, what we need to run up to the overhead on the inside, and then that way we can work out
if we're going to do a new, like we'll definitely need one new solar feed, whether we do 2 new solar feeds, whether we'll do just whatever else needs to go up there. If we need to take any ace out there, I don't think we will. And then just the new cables for the Victron screen, really, and then anything else. But it'll definitely be at least the Victron cables for the screen and one solar circuit, and then potentially another solar circuit. The solar circuit that's going to be looking after the 5 225 watt panels is going to be what, 20 odd volts at probably close to like 60 amps, 50, 60 amps. So you would need at least a 10mm cable going up there, which is what is there at the minute. I'm just going to work out what I can do with the cable coming out of that box. If I can avoid doing BPs and do something like an MC4, then yeah, okay, sweet, we'll keep that original feed there. But the moment you have to put a BP on it, it makes it not compliant. So if we can't get any length or anything on that cable to put MC4s on it, I'll just delete it. I'll keep that box there and just cap it off and run a new feed up, because yeah, we need it to all be compliant as per the wiring standards. So yeah, my job now is to attack this tunnel boot this morning, and yeah, I'll get cracking on it, and I'll try and do better today. I've given you updates throughout the day. We are finally making some progress and getting some blue gear in the box. These are all just cables that are still connected, and I just finished off doing the 240 AC stuff on the Multiplus. So these two are like an aftermarket install, and then there's another two that come through over here, which are the factory. One of these is your shore power inlet, one of them is your power to your outlets. One of these ones is your generator input. One of these ones is there's 2 double power points in the front box. So you've got one up here in the generator box, and then that's your generator inlet. And you've also got another one just in here. So the 2 that went to the front, the 2 circuits, they weren't going through any circuit breakers or anything before. So yes, realistically, I shouldn't have had to add these circuit breakers here, but because I want to have them on a RCBO, I've added 2 Max 9s, which are both double pole RCBOs. Yes, I'm missing a pole filler, but that will go in shortly. And then the ones that are inside will control the outlets in the van. As these ones will do them as well, because they're like an isolator, but these ones are mainly for this aftermarket stuff that got installed that didn't have any protection on it. And then you've got a changeover switch, which I've wired up, so it'll be like shore power and generator. You sort of just got to wing it and work out what's what once you've done, but hopefully shore power because it's over that way, and then generator because it's towards the front. And then now what I'm going to work on is wiring up the 70mm cables for the 3 kVA Multiplus from the battery. Wire them in to up here, plug in the RJ45 and put the cover back on, and then the Multiplus is done. And then I can get cracking on the rest of the panel and all the rest of the Victron gear. We've had a decent time of it, just getting everything into place, or where we think it's going to work, and just running some cable ducting, just all the fun stuff, working out like where the compressor is going to sit. I've measured up the battery box and sent it off for cutting on the CNC machine. I've got the 2 batteries here. The one on the left already charged up, so I'm just charging this one up on our display unit, and at 115 odd amps, and it's just plugged into our shore power. So I'll leave that overnight to charge, get in the morning, and I'll show you the process of that. You would have seen it in some of our other videos as well. Both batteries, these are the 350s, fully charged. I'm going to turn both of them on and get them ready for balancing. Let's see, all right, sweet, they're popped up here now. All right, 3.43 and 3.48 are our cells. 3.44 across the lot there. So we're going to leave these for a few hours. Just let them balance, do their thing, and all these cells should be exactly balanced across, wrong battery, all 8 cells. So yeah, see how we go. All right, so it is now 3:40, same afternoon. Battery 1, 3.67 volts, and our average cell voltage is 3.418. Go to the other battery. Average cell voltage is 3.420. So they're 0.002 of a volt in difference, and yeah, 13.68 for that battery. So they're all balanced up, ready to go. We've just got the CNC'd battery box. So we are just sealing it up with the Sikaflex from the inside, and then this one's going to have a Perspex lid. Now that was just a request from the customer because he wanted, if he goes through a puddle or he goes through, I don't know, a bog hole and something gets in there, he just wants to be able to see, which he can quite easily do if he pops up the bed and then just jumps in here and has a look down here. So we've got most of the Victron stuff hooked up. We just need to do the fuses, like the main fuse and the circuit breakers. And then we have made a plan with up here, which I'll show you. Basically, we're going to rip this panel off, which is actually glued in, so it's a punish to rip off. But try our best to do that. We've run up our extra circuits, which is our HDMI for the servo screen and the 6mm twin for the extra solar circuit. And we'll have to get up in the back of that panel once we cut it out, drill a hole through the top. We're still waiting on the 225 watt panels. We have some here, but we need more to do it, which that was always part of the plan. We're just going to work out whether 200 fit or 225 fit. And then we've got just some more of the Enerdrive pressure sensor modules coming for his tanks, and another one of the tank sender modules. So that will plug into the Servo GX. This is going to be mounted to the battery box somewhere, which will talk to the servo, which will then in turn do all of our where is the servo? Servo's up there, waiting to go in, and that will, yeah, look after all of our tanks. All right, so we have managed to get most of the system up and running. We've got another sneaky solar controller up there, tank senders, solar controller. I'll take you all through it later on. This is where we're at. So I got the screen plugged in just from an extension, and basically it's time to power up the system and turn both batteries on, hit this circuit breaker. Our fuse panels just lit up, and I'm going to turn on our loads, and that should power up the screen. So the screen is powering up now. I haven't set up the UI or anything on this, so it's still going to be in the old update. That's a win. That's a win. That is a big win. Yes, that's sick. Alright, so I'm just going to show you something real quick. So because we've maxed out the servo on like its inputs, so for the 2 tank senders I've had to use a USB hub. So it's a powered hub, so like a PoE but for USBs. And basically me just opening it up just then, and the tank's coming up means it's working, which is sick. Alright, cool. Batteries are full. Cool. I'm not going to set anything up just yet. I just want to make sure that it's all there. The inverter hasn't come up because I haven't switched it on. So the inverter, there you go. There's the inverter. And I haven't turned on the solar, so if I turn on that one, there we go, the solar, the big solar one that's controlling the 5 big ones. There we go, on VE can. That's sick. And then if I was to hit the next 2 circuit breakers for each of the DC chargers. Yeah, Orion XS, Orion XS. Oh, I missed the middle one. We should get another Orion XS here in a second. Bang. That's awesome. That's perfect. That's everything. So, yeah. Now, it's just the fun of programming it all, which is going to take a hot minute. But that's going to be my objective for this afternoon. Program it, give it a pressure test in like the way it is now. So that'll be like run a kettle, test the AC, all that jazz. We'll clean up all the wiring and stuff in here, put the lid on the battery boxes. Happy days. We powered up and we're good. We made it. It's been a couple of days since I filmed the last video, so I can't remember what we were up to, but the last 3 to 4 days and over the weekend it was just a push to try and get this done on time for the customer. But we got good news. This looks a bit different. This looks very different. And this is something that this van has never had. Tank monitoring, which is awesome. So I'm gonna hand the camera over and give you a full run through video now of everything that we've done on the van. And yeah. All right, specs for this van, it's a 2016 Bushtracker. It came to us with a 400 amp hour lithium, an Enerdrive 30 amp DC charger, which is superseded now, an Enerdrive 60 amp AC charger, a tri-solar solar controller, which is looking after the solar on the roof. There's just had like a Enerdrive BMS system running the battery, and a couple other bits and pieces just with extra fuse panels and whatnot. Now, what we've upgraded it to, he's running 700 amp hours at 12 volt of lithium across 2 batteries, so 2 350s, a Victron Multi Plus 2, 3 kVA, so it's a 2400 watt pure sine wave inverter, and it will surge up to 5500 watts. Running 2 50 amp DC chargers from his Ram 3500 that he's towing the van with. He's got 3 solar controllers. We've got a 150/70, which is looking after the roof. We've got a 120, which is looking after the 2 panels on the front, and then we've got a 115, which is looking after his solar blanket input. He's got a full Victron servo monitoring system, so Victron shunt, tank monitors, all that jazz. The tank before had no tank monitoring at all, and now we've got monitoring across all 5 of his water tanks. They're all 4 fresh waters and 1 potable, so 1 drinking water that runs through the filtration system. And yeah, I think I've forgotten a thing or 2, but let's jump in the tunnel boot and I'll show you what we've done. All right, I'm gonna use this light just for a bit of extra natural light for the camera because it does get quite dark in here. But basically, this is the same area that all the Enerdrive stuff was in, and now it's all blue, which is good. So obviously batteries in an AS3000 compliant box. The batteries are also AS3000 compliant. They need to be IEC 62619 certified, which these ones are. We've got a vent hole to the atmosphere, which keeps it compliant. Fully sealed box. Perspex lid was a customer request. This here is a Victron 3 kVA multi-plus. So it's a, like I said, 2400 watt pure sine wave inverter, 5500 watt surge inverter. This is also a battery charger. So it's a 2-in-1. It's inverter and an AC charger. This will charge these batteries up at 120 amps, and he has 2 selections, so he can charge from 2 spots. He's got a generator box in the front, which he has an AC input from. He's also got a mains shore power on the side of the van. So he's got a selector switch, which is just down here. We do also have 2 RCDs down the bottom just to make sure everything's protected, as well as another RCD box up in the overhead up top. I'll show you that later. Our next biggest charging input would be our 2 50 amp DC chargers. These are the new Orion XS's. So these will both have an input fuse here from the car, and then they've also got output circuit breakers down here, which are from the charger to the battery. Now these are manual reset circuit breakers, so if something does trip, we can just simply flick that and it will be good to go. Solar controller. Again, our solar array is quite large, hence why I've gone with a bigger controller, but we have kept it in line with all the AS3000 specs. Main switch for both solar arrays, and the bigger solar array, which is solar array 1, is going to be putting in anywhere between 50 to 60 amps on a good day. It's 5 225 watt panels on the roof, so he's got a lot of juice up there, but because the solar string is larger than 3 solar panels per string, he has to have a fuse on every solar panel, which we've done, but it's on the roof and it's all underneath one panel. So if it ever needs to be accessed, it can be. You just need to take up one panel. Our 120 does the 2 110 watt solar panels on the front of the van that we've added. So that's a separate solar string to the roof. And again, it comes through our solar 2 solar switch. And then just around the corner here, we've got another solar controller, which is just doing his solar blanket plug-in. That doesn't need the solar isolation switch because technically you isolate it by pulling it out. These 2 units here, now this is where the servo, we maxed the servo out, which is this Victron monitoring unit. This is the Mark II unit, so it's got the extra CAN port, which is part of the reason why I got a CAN input one of these, because you can actually get these in a VE Direct. I'm pretty sure this one's got, yeah, it does have a VE Direct anyway, but we've got the CAN model. But even still, with getting this in the CAN model, which is obviously CAN bus communication to the servo, so we didn't take up another VE Direct, we still maxed out the servo. So what we've done is over here underneath the solar controller, we've got a little USB splitter, which is looking after both of our tank modules. So we've got 3 tanks in one and 2 in the other to do all 5. So with the voltage sensors that we're running, we could have only maxed out one of these doing 4, so therefore we needed 2, but we only had 1 USB, and that is also incorporating that the screen is running off a separate USB. So this servo she's running to the max with all inputs under, all inputs are being used. Over this side, we've just got some more fusing, so there's an inverter and main switch circuit breaker. Now, you'll see this cable, which is on the battery side, that runs this fuse panel. So that's got our battery monitor and our brakes on it. That is purely so our servo system doesn't disconnect in the way of, if like, it'll only turn off if the batteries are flat, but if the inverter trips, the battery monitoring system ain't gonna trip. It's gonna stay on. And then this solar panel is just powered off the other side of your main switch. Don't mind this wiring here, that was all done before us. That's just the factory stuff. Same with the switches and stuff up here. And then we've got more water pump switches over here. Now, our circuit breakers over here, you've got your load, so all your 12 volt out, your solar 1, your DC charger, and then the bottom one does the electric lift jack at the front of the van. Switch here does the trigger system, which is basically a remote control lighting system. I will show you that. And then this system here does something I'm not going to tell you about. We've sorted out and looked at pretty much everything outside of the main part of the van. As you can see, that electrical system sits under the bed, which he can access from inside the van. And if he needs to hit the AC transfer switch, it is easily accessible from this location and from inside the tunnel boot. So this is the control panel. This is where all the magic happens. Just disregard this stuff. This is stuff was all these like cellular gear and stuff which is already done. We've just changed some of the positioning of to try and make it look a bit neater, but that was not us, so don't judge any of the wiring and stuff that's up there. All right, so basically Victron screen, which looks after the whole Victron system. Down here, we've got up and down switch for his roof mounted antenna, inside and out for his speakers, and then there is a sub underneath the seats below us. Fusion head unit, which just basically controls he can do like music, FM radio and whatnot, and then controls the sound from his TV to spit it out from the inside or the outside speakers. This one's a bit interesting. He's actually got a full satellite dish on the roof, which connects to his like Sat King box. Now you can control it from here. This bit up here is just the control screen for his little energy source in the front of the front box on the front of the van. Diesel heater control and hot water control, and then his switches, which you can see, fridge, his water pumps and stuff, cabin lights, that's why they just went out, courtesy lights, which are the ones in the tonneau boots, and then all his radio gear, which is all this stuff up here, and all his cellular gear on the right side up here. So we'll take you through all the stuff that we've done, obviously, which is all the Victron stuff. Now, this is the new user interface, so we've done like all the latest updates and whatnot. This will, well, at the moment, it's connected to the Wi-Fi in the workshop here, and it will send all the data from this up to the cloud. So I can see all of this, like if I'm at home overnight or whatever, and it's still connected to the Wi-Fi here, I can see exactly what's going on in the system, and I can even turn the inverter on and off via my phone, my laptop, anything that you can access the cloud, you can access this. You have to set it up, and because this customer has he's got a cellular system in the van, which will run off a SIM card, I will pair it to that when he picks it up, and then he's good to go. So when he is away from the van, he can still see exactly what's going on with the van. So, all right, Victron system, obviously batteries, percentage, discharging, so time till discharge, voltage, he's currently using 8.5 amps, and we're currently using 113 watts. It's just dropped down because the fridge is running. So your amperage and your watts are relative to each other, and then obviously you got alternator here. Now you're going to be confused because you're going to see one alternator, one solar yield. This is the perks with the Victron stuff. We click on this and you got, oh, okay, there's 2 DC chargers here, and we click on the solar yield and there will be 3 solar chargers there. So this is one of the main perks with the Victron systems, and I guess the accessibility of the system, and how you can make sure you have more than 30, 40, 50 amps of DC charge, and make sure that you're getting 100% efficiency out of all of your solar arrays. So at the moment we got nothing on, our inverter is not on. I'm going to click on here and you can hit that there and change it that way, or you can also just do it from any screen on the top left. You have this control. I'm just going to hit that inverter on, because we have the mains power plugged in outside the van, but I don't want that to come into play yet. Now you'll see, all right, yeah, we are pulling a bit of power. I'm gonna grab the air conditioning remote out of here, and I'm gonna go to start up the aircon. You'll see our power is pulling up there. I wanna try and get it down to 16 degrees, which I've got, I'm cold. So you will see and you will hear in a second that it's going to, because it's an older van, it'll be an older model, and have dark start built in, and it's going to pull a massive amount of juice when this condenser starts up in a second. Okay, so we can see the aircon now started up. We're pulling 700 watts, which is equivalent to 61 amps off the batteries. Just going to turn that off now, just so I can show you us pulling some more power off the batteries. At the moment, all it's doing is the aircon is powering down. That's what the 170 watts is. I'm now going to turn the sandwich press on. So the sandwich press is pulling 160 amps off the batteries, 1800 watts in AC power. Aircon is fully off now, so we can see that just the sandwich press is pulling very close to 150 amps. I'm going to turn the sandwich press off here now, and I'm going to hit my kettle. Kettle is going to pull more power because that's a bigger power consumer, and it is pulling very close to 180 amps. So roughly both of them put together, I'm going to turn on the sandwich press now. We are getting 350 amps of discharge through our battery system. We are completely off grid. This does not say charging or assisting. We are completely off grid, purely running off the batteries, and we're discharging at 350 amps, not a problem in the world. Now you can see here, this is our AC wattage. We're doing 3,500 watts, which is well inside both what the inverter and the batteries are capable of. and this system will be able to run at 3,500 watts for as long as you want it to. Pending that there is battery storage there, you are sweet. You do not have to worry about anything. All right, now what I'm going to do while them two are doing their thing, I'm going to go onto our little control here, and I'm going to turn this to on, and this is what I mean by assisting. So it's going to take into account now that we are plugged into mains shore power, which will flick over in a second. There we go. And it goes, okay, sweet. Yes, we are connected to shore power. We want to charge our batteries, but we're pulling more on our AC loads than what we can put in, or what we can handle from our AC mains coming in. So if I am to say turn the kettle off, we're still running the sandwich press, it's going to go, okay, yep, we're still pulling mains power through our PowerPoint system, through our PowerPoint circuit, our outputs, but it is not more than what we're getting in from our shore power. So we have power left over, therefore it's still going to give us roughly 40 amps of charge. Now, if I turn the sandwich press off, it's going to say, all right, yep, we're not pulling anything at all on our outputs anymore. Let's give the batteries that full 120 amps of charge, which you can see it is doing. So that is how the Multiplus works with its AC transfer switch and with its assisting factor. It is a very, very good piece of kit, and that is why we rely on them and install them so much, because we swear by them. Basically, they're the best bit of kit on the market, and Victron have also now in the 12 volt range brought out a 5 kVA system, which basically kills any need until there are more efficient ways to charge a 24 and a 48 volt system to go to those voltages. So we're going to let those batteries charge up and do their thing. You also obviously have our brief overview screen of the new Victron system, and then we can also change the view of it by hitting that as well. It's just another little perk. All right, water system, plumbing, tank levels. I will show you obviously underneath the voltage sensors that we've put in, and like I said, we have made these be compatible with the servo, even though we already maxed out the servo. Basically, I've emptied these because he's picking the van up tomorrow and he's going to be towing, but each of these tanks is 85 litre. He's got 1 potable water, so drinkable, and then 4 freshwater tanks, 3 up the front, 2 up the back, all running through. Before, when the van came to us, he had no idea how much water he had in any tank. So notifications if there's any errors or overcurrent alarms or under voltage alarms or anything, which there isn't, and then basically settings. It can be a whole nother video, so I'm not going to bother going through that. Just going to show you this here as well. So this is already in, obviously we just had to rewire it because the aircon and the hot water system only ran off shore power, and then the outlets ran off of the inverter that was in here, but because it was only an 1800 watt inverter, we just took the cover off this essentially and just rewired that. So basically all the outlets and the aircon and the hot water system all run off the inverter system. Let's go to the exterior of the van and we'll show you everything that's happening on the outside, including the solar. So our trigger system, which is our remote switching system, runs off this. Now I've got to remember what's what, but basically he's got 2 lights on each side of the van. No, we didn't install these, but I thought it would be handy to show you because it's a very good bit of kit and handy for a lot of caravanners, but he just keeps this in his car. As you can see, there's a lot of solar on the roof. We've split it up into 2 circuits. So the 2 at the front, one reason, different size, they're the same voltage, but different wattage size. And because they are on the slanted section, if the sun is rising at the back of the van and these panels were to have no sun and the rest of them would have sun and they were all in the same array, you're not going to get much power out of that. So we've separated it, ran a new solar circuit to the roof, which just looks after these 2 110 watts on either side of his hatch on the roof here. Then the 5 that are in the main section of the roof, there was 5 there before. They were Enerdrive 150 watt panels. They were a little bit shorter and a little bit less wide than what's up there now. The ones up there now are 225 watts each. Thanks to Siri, he has 1,125 watts on the roof, which that 70 amp charge is going to handle, and which is going to punch out pretty close to 70 amps, which is a lot of juice. As long as there's sun, he's not going to have to worry about being off grid for too long. If you're getting roughly anywhere between like 50, 60, 70 amps of charge in over 8-hour day with the sun out. And yeah, you might use his gas cooking in the van, so he's not going to use an induction cooker. He might use the electric hot water system. He's going to have an abundance of power, and realistically the generator that's in this box shouldn't be used much, if at all. We've basically been through everything in the van, and one of the last things that we'll do for the customer is a vehicle electrical compliance certificate. I'm an electrician by trade, so we are liable, licensed, insured, all that jazz to sign off on a vehicle like this for all the 240 stuff, whether that's for you getting your vehicle engineered or it's for insurance purposes. We have had a couple of customers tell us in the last sort of 12 months, oh, we've told the insurer that we've upgraded to lithium batteries and now they don't want to insure us. This bit of paper with my scribble on it will basically give them no reason to not insure you. It takes all liability off the insurer, and yeah, it just basically says that it's done as per the AS3000 and it's done to spec of the current Australian wiring standards. For jobs, we'll also give the customer job installation sheet, which will basically go through every part that we've supplied with serial numbers, their warranty on each part, and basically just we scribble on it, they scribble on it to say, yep, this is what's been installed, and that's just for the customer's records. That's pretty much it. I do make it sound very easy. This job was a very long job and a fair bit of a punish, purely just because of the amount of, like, there was a licensed electrician that worked on it, there were the people that did the outside lights, there was people that done all the cellular stuff, and it was just like behind this, as you would have seen in the earlier in the video, it is just a spaghetti nest of just wires. So this job was a lot harder than usual, but we've gotten it done, and we've gotten it done in the customer's time frame. So I hope you've learned a thing or two. I hope you've liked what you've seen. If you've got any questions, put them in the comments. I'm more than happy to answer them when we get the chance. And yeah, happy camping.